Okay, hello. Today our discussion topic is we'll discuss magnetic dipole moment of a revolving electron. When an electron revolves around a nucleus, a magnetic moment is generated. So we'll calculate it. Here an electron is revolving around the nucleus in anticlockwise direction. So we'll write that current is charge upon time. Charge here is electron, so I can write T. Here T is the time period, means to complete one rotation. Okay, so current I is equal to E upon T. T I can write time period. In this case we can write time period T as distance upon velocity. So 2 pi r upon b. B is the speed of the electron or velocity of the electron. 2 pi r is the distance, one rotation. 2 pi r is the one rotation, one complete rotation, because we have written capital T. There is a time period to complete one rotation for one charge, that the current generated, that is here I. Now if we put here, we will find I is equal to E V upon 2 pi r. I is equal to E V upon 2 pi r. Now we know that magnetic moment, from the definition of magnetic moment, mu L, L we have written for orbital or angular momentum. Okay, so mu L we can write the magnetic moment is I, current, into area of cross section IA. So I can write here I pi r square, or mu L is equal to I from here, from 1, suppose I from 1, that is E V upon 2 pi r into I pi r square. Pi cancel out, so this becomes here E V r upon 2. Magnetic moment becomes E V r upon 2. Now what we'll do, let's multiply and divide mass of electron in the numerator and denominator. So now your mu L or magnetic moment will become E upon 2 me. Me, my mass of electron, I multiplied in the denominator and in the numerator, that is me Br. I multiplied numerator and in denominator. Other things are, rest of the things are same. Mvr is your angular momentum, okay, and E upon 2me will be a constant. So we can write your mu L is equal to E upon 2me L. If we write vectorically, some important thing is there, I will now describe. Mu L is equal to minus E upon 2me L vector. The negative sign is for the direction of the magnetic moment. See, from here, if an electron is moving from here, if an electron is moving anti-clockwise, then what happens? According to the assumption, we treat the current is in the clockwise direction. So from right hand thumb rule, if current is in the clockwise direction, then my thumb will be the direction of the magnetic moment. So this cross section means inside the board. So if a electron is revolving anti-clockwise direction, the magnetic moment direction will be inward to the board. And instead of taking an electron, if we had taken an positive charge, suppose an positive Q charge we have taken, if it is rotating, then the magnetic moment will be in the upward direction. Okay, so this direction we are describing as vectorically. Now you can see that we will find out the ratio. Our target is to find out this ratio, that is gyromagnetic ratio. So from here you can see that let's do here. So mu L is E upon 2me L, that will become mu L upon L is E upon 2me. This is your gyromagnetic ratio. When you will put all the values, and it is a constant, experimentally it is proved by various experiment, this ratio is a constant, and this ratio is called your gyromagnetic ratio. The value of gyromagnetic ratio you can easily find out by putting the value of E, that is, what is the value of E? Electric charge, that is 1.6 into 10 to the power minus 19 coulomb, 2 into me, mass of electron is 9.1 into 10 to the power minus 31 kg. Okay, so it will become this value, it will become 8.8 into 10 to the power 10. You can calculate of yourself. Of course, the unit will be coulomb per kg. Write like this, coulomb per kg. This is one. Now the second thing is, we will calculate Bohr Magneton. To calculate Bohr Magneton, you can see that from Bohr hypothesis, you know that angular momentum is discrete. From quantum mechanics or from quantization of energy, you can say that angular momentum is discrete. So putting the angular momentum in this equation for atomic level, you can see that the L value is nh by 2 pi from Bohr hypothesis. N is a natural number, where n is 1, 2, 3 like natural number. N is the first cell, first orbit, then n is equal to 2 is the second orbit. Okay, so you will quantize the orbits, different orbits you will get. So putting for first orbit, for n is equal to 1, you will get L is equal to h upon 2 pi. Putting it for this equation, your mu L will be E by 2me into into your h upon 2 pi. So the expression becomes mu L is equal to EH 4 pi ME. This is your mu L minimum. This is called your Bohr Magneton. This is called your Bohr Magneton. Mu L for minimum. Minimum means we have taken the for the first orbit. This n is equal to 1. Okay. Now if you put for all the values, that is, let's do it. Let's do it here. You will get mu L is equal to E H by 4 pi ME. So put all the values. You know E is 1.6 into 10 to the power minus 19. H is 6.6. This H is the Planck's constant. H is the Planck's constant. Its value is 6.6 into 10 to the power minus 34 joule second. Unit is joule second. 5 unit is pi, has no unit. Its value is 3.14. It's a constant. Mass of electron is 9.1 into 10 to the power minus 31. So putting all the value, you will get a number 9.27 into 10 to the power minus 24 ampere meter square. Okay. Now how the unit came ampere meter square, I can shortly show you, because sometimes you get confused that how the unit became ampere per meter square. Now see, here E is the charge unit. I can write as unit of charge is I into T. So I can write I is ampere, time is second, H is joule second, multiplication you can write. Now 4 pi, these are the constants, no unit. Mass I can write, I can write energy, because you know that energy is equal to mc square. So mass I can write energy upon c square, that is E upon c square I can write, or E upon c square means joule power. C is the speed is again meter square per second square, so that second square will go up, so joule second square per meter square. Okay, this is your joule second square per meter square. So this is your expression in term, this is your mass expression in terms of joule second and meter square. So I can replace this mass in joule second square per meter square. Second square cancel, joule cancel, meter is the denominator, it will go up, so the unit become ampere meter square. Okay. Now another thing I will say, why this is mu L, not other symbol. L we have taken because we are calculating the orbital magnetic moment due to the orbital motion. Okay, but electron has intrinsic spin also, where we denote it as mu s, but I'll not discuss about spin magnetic moment. So here L subscript means our calculation is due to the magnetic moment. Our calculation here, the calculation is due to the magnetic moment due to the orbital motion. Okay, so it's a very important thing, and from many applications, it is some many important questions. If you are studying in class 12th level, it's an important question. In the other classes we will discuss more and solve some questions about in this topic also. Okay, thank you.